CubeSats. The term CubeSat is used to refer to satellites that adhere to what is known as the CubeSat standard. These miniaturized satellites are often 10 centimeters cubed, but can be scaled up as needed. Their small size significantly lowers their costs, decreases the amount of materials needed to construct them, and conserves space, which allows them to rideshare with other spacecraft. These developments have allowed more actors to access and conduct research from space than ever before, and to date, more than 50 nations have participated in the launching of over 1,500 and counting of these miniaturized satellites. Now, you may be wondering where CubeSats were first popularized. CubeSats are an emergent national and transnational technology that's credited as being developed in the United States in the year 1999 through a partnership between California Polytechnical State University and Stanford University. However, this is not where the story of CubeSats truly began. CubeSats represent one example of how centuries of scientific and technological advancement across disciplines, and in particular miniaturization, can culminate into a unique novel artifact. The development of CubeSats was not just one heroic feat despite being credited as such. Instead, the creation of this technology is the result of increased understanding and development of reliable technologies such as batteries, radios and communication systems, conductors and semiconductors, durable construction materials like metals, solar panels, as well as electrical wires, and a geopolitical economic climate that has increased interest in funding for space exploration. Considering the diversity of CubeSat components and uses, it should not come as a surprise that a variety of actors are instrumental in the production and regulation of these miniature satellites. Many of these actors can be categorized as national or transnational public agencies, like governments or the United Nations, or entities that are subsidized, regulated, or contracted by public agencies. Because these nonprofit, public, and private actors maintain relationships with public agencies, CubeSats affirm the theory of publicness. If you have questions about publicness theory, don't worry, we'll discuss this in more detail during our Who's Invested in CubeSats section. For now, let's explore how various actors interact to ensure the regulation of CubeSat components for quality and safety, verification of CubeSat licensing, and adherence to orbit and deorbit guidelines. Before a CubeSat device can even be considered for launch, the components required for constructing these nanosatellites must be developed and arranged in accordance with national, transnational, and in some cases, corporate regulations. The regulation of CubeSat components helps create standardized rules and enhance the quality and performance of these devices. The regulation of CubeSat components is also important for safety. Accordingly, there are a wide range of safety requirements that must be fulfilled before CubeSat operators are permitted to apply for licensing, and upon receiving licensing approval, granted permission to launch their devices. Specific safety requirements vary depending on the country the CubeSat is being developed in or being launched from, the payload it's carrying, as well as its overall mission. Furthermore, companies and corporations like Planet Inspire have implemented self-imposed rules and continue to advocate for additional regulations. The purpose of this is to ensure CubeSats fulfill all safety requirements, such as successfully burning up when re-entering the Earth's atmosphere. This safety assurance also decreases the risk of CubeSat malfunctioning and potential hazards CubeSats might pose in an increasingly crowded space environment. After ensuring the components for a given CubeSat meet quality and safety standards, a CubeSat operator must obtain a license before they're granted permission to launch their CubeSat. Without the proper license, a CubeSat device will not be allowed to rideshare with other spacecraft or be launched into space to complete their missions legally. Obtaining licenses for satellites can be a lengthy process, so be sure to plan ahead.
You might be wondering, if CubeSats are truly nanosatellites, then why do we need national and transnational agencies to regulate how and when CubeSats orbit and deorbit? Doesn't the compact CubeSat design eliminate collision risks and space debris? This is actually a commonly held myth regarding CubeSats. CubeSat's small design does decrease each individual satellite's potential for collision. However, there has been an exponential increase in CubeSat launches since 2013. With over 2,500 satellites orbiting Earth currently, at least double this amount, over 5,000 satellites that are non-operational still in orbit, and millions of pieces of debris in orbit, more and more CubeSats contribute to an overcrowded orbital space environment. Thus, as additional actors like SpaceX and NASA, for example, launch larger quantities of CubeSats, the overall risk for collision increases. As small as a 10 cubic centimeter satellite, which is the same size as a 1 unit CubeSat device, will most likely cause catastrophic satellite breakups and spacecraft damage. Space collisions can start chain reactions too, because released space debris can later collide with other orbiting spacecraft. More problems arise if space debris with substantial size loses its orbital velocity and begins falling back to Earth. Some of the space debris will burn up upon re entering Earth's atmosphere, but larger pieces will pose safety risks. The compact CubeSat design does also present problems for trackability, especially when only one CubeSat unit is used and the design is not scaled up. When CubeSats are lost in space, they pose hidden collision risks and have the potential to become space debris and pollute outer space if they escape Earth's gravitational pull. While CubeSat's design is the basis for the technology's biggest problems, this very design has simultaneously allowed for the technology's widespread success. The unique design of CubeSat significantly decreases the cost of satellite production and fosters a market where access to space exploration and research has reached unprecedented levels. Looking to the future, CubeSats are being experimentally used as spacecraft for interplanetary travel without the need for humans on board. This would yet again revolutionize space exploration because intergenerational space journeys could take place without risking human life or worrying about how to sustain a human population. To recap, we covered what CubeSats are, provided a brief CubeSat history lesson, introduced how publicness theory is relevant to CubeSat technology, debunked a commonly held CubeSat myth, discussed potential problems and risks associated with CubeSats, and opened our eyes to what the future might hold for CubeSat technology. Thanks for accompanying us on this journey into the world of CubeSats. We look forward to guiding you through the rest of the course.